Good morning all. Today our topic is insertion sort. So we will discuss today about this insertion sort, how this algorithm works, how we sort an array by using insertion sort. We have earlier studied about selection sort and bubble sort. Today we will discuss about insertion sort. Now, in insertion sort, first we have to divide this array into two parts. First is sorted subarray and second is unsorted subarray. So we have to divide this array into two parts. First is sorted subarray and second is unsorted subarray. Initially, we will start with first element as sorted array and remaining elements as unsorted. Is it clear? So this array is given. We have to divide this array into two parts. First is sorted subarray. We will denote sorted subarray by SA and unsorted subarray by UA. So this is our sorted array and this is our unsorted subarray. Okay. We know that if an array has only one element, that is already sorted, because there is no need to compare with other elements because there is no other element. So one element is sorted always, either in descending order or in ascending order. Single element is always sorted because there are no elements, no bigger, no smaller. So first element is always sorted there. Now, in this insertion sort, what we have to do? We have to compare next element. We will start from unsorted elements, unsorted arrays, first element. Now we will compare this with unsorted array element. Unsorted array has only one element, so we have to compare this element with this element. Now, what we should do? We should compare this element with this element. We have to find appropriate position for this element. So we will compare this element with this element. Okay. Now, first we will store this element in a third variable, that is temp. Temp equals to 5. Now we will compare this element with this element. If 5 is smaller than 6, what position should 5 acquire? Obviously before 6. So we will shift this element this side. We already have some backup for this variable. Whenever we need this 5, we have our variable, that is temp. So this is the backup for this 5. Now we have to shift one position right to this 6. What will happen? What will happen? 11 to 7. If we shift this 6 one position right, then obviously 5 is replaced by 6. Okay. There is no other element in this array, sorted array. No, because initially it has only single element, so we have to do only one compare, 5 with 6. Now there is no other element, so we will shift, we will store this 5 at first position. Clear? Now this is our sorted array and this is our unsorted. Okay, now what is the first element of unsorted array? 11. Now we have to find appropriate position for this 11 in sorted array, sorted subarray. We will compare 11 with this 6. We have to compare first element of unsorted subarray with elements of sorted array starting from right to left. Unsorted array will start from left to right, and whenever we will compare first element of unsorted subarray with the elements of sorted subarray, then we will start from right position. Now we will compare 11 with this 6. 11 is bigger than, first we have to store this 11 into a variable temp. Now value of temp is now 11. Now we have to compare this temp variable with 6. Is 11 is bigger than 6? Yes. So there is no need to shift. We will shift this variable to this memory location. So 5, 6, 11, 2, 7, 3. Now this is our sorted array and this is our unsorted array. Now what is the first element of unsorted array? 2. So we will 1, 2, 3, 4, 5, 6, 11, 2, 7, 3. Unsorted array and sorted array. We have to compare this 2 with, first with 11. If needed, we will compare 2 with 6. If further needed, we will compare this 2 with 5. So when we compare this 2, we have to store this 2 in a variable temp. Now we have to compare this element with temp, starting from right to left of sorted subarray. If temp is 2, first element of sorted subarray is 11. 2 is less than 11. Yes. Actually we are trying to find appropriate location or position for 2. If we are arranging this array in increasing order, so what position should this temp require? We will find. We have to compare this 2 with 11. 2 is less than 11. So what we have to do? We have to shift this 11 with one place right. So what will happen? What will happen? 5, 6, 11, 7, 3. Now we will compare this 2 with 6. Again 2 is smaller than 6. Obviously 2 must be 1 or some place before this 6. So again we will shift this 6 here. So what will happen? 5 question mark 6 11 7 3. Now again we will compare this 2 with 5. What will happen? Again 5 is shifted one place right in this array. So 5 6 11 7 3. There is no other element in sorted subarray if we are traversing from right to left. So we will copy this this temp variable at first position, because there is no other element, so there is no need to compare with other element. So now what we should do now, this is our pass 1, after pass 1, pass 2, this is our pass 3. Now what will happen in pass 4? What will happen? I am erasing this side. So what will happen in pass 4? In pass 4 we are having 2, 5, 6, 11, 7 and 3. This is our sorted array and this is our unsorted array. Again, what is the first element of unsorted array? Obviously 7. So now our task is to find appropriate location for this 7. We will do. What we should do? We will compare this 7 with this 11. We will store this 7 into a variable temp. Now temp is compared with this 11. Obviously this temp is this time less than 11, so we will shift 11 to one right position. So 2, 5, 6, 11 and 3. Now this is question mark. Now again we will find this 7 with 6. This time this 7, this temp variable is greater than the element 6. So actually what we are doing, we are finding appropriate position for this 7. We know the 7 is 11 is lesser than 11, but it is greater than 6. So if we compare this element with 6, what we get? That this temp variable is not lesser than 6, though, so there will be no shifting this time. What will happen? 2, 5, 6, 7, 11 and 3. It's clear? This is our pass 4. This is our pass 4. Now in pass 5, how many passes should be there? 5 passes, because we are having 6 elements. 0, 1, 2, 3 and 4 and 5. If we are having n elements, then passage must be n minus 1. So here n is 6, so we need 5 passes. 4 passes we have done. Now this is the last pass. Pass 5. In pass 5, what will happen? This is our sorted array and this is our unsorted array. Now our task is to find appropriate location for this 3. 3 is stored in a variable temp. So this time value of temp is 3. Now we will compare this temp with this 11. Yes, it is lesser than this 11, so we will shift 11 to one position right. So 2, 5, 6, 7, 11. Now again we have to compare this variable with this 7. Obviously temp is lesser than this, so again we will shift 7 one position right. Now again we will compare this 3 with 6. Again 6 is shifted. So 2, 5, 6, 7, 11. Again 3 is compared with this 5. So 2, 5, 6, 7, 11. Now we have to compare this 3 with this 2. 3 is not less than 2, so there will be no further right shifting, and this temp variable will be stored at this position. So 2, 3, 5, 6, 7, 11. So this is our final result, sorted array. I hope you understand this algorithm. Now we have to write a code for this, because we have to run this program also on the system. So we should also know what should be the code behind this. Okay. Now for I equal to 1 plus y, j is greater than 0 and is j minus So this is the code behind this. Now so value of I is here 1. So 0, 0. So the value of I is here 1, because we will start from second element and we have to compare with this element. J equal to I minus 1. J is initialized with I minus 1, because if we compare this element, so we have to start from 1 count lesser than value of I. So initial value of j equals to I minus 1. Now what is the value of I? 1. A value of I is 1. So value of j is 0. Now temp equals to a 0. What is the value of I? 1. So what is the value of temp? Temp equals to a 1. So here the value of temp is 5. Now j, value of j is 0 and I is 1. So 1, 0 is less than equals to 0, condition true. And a of j, what is the value of a0? 2 is greater than 10. 2, sorry, this is not our problem. Value of temp is here 5 and j is 0. So a of j, 0 is greater than equals to 0, condition true. A of 0 is greater than temp. Yes, a of 0 is greater than temp. So we have to right shift this with first element. So 6 is right shifted to at position 1 or in the place of 5. So it becomes 6 and j minus minus. What is the value of j? Value of j is 0 minus 1. This is minus 1 this time. Again this loop will continue, but this time this condition is false. So minus 1 plus 1, a of 0, 10. So what is 10? 5. So 5 will replace 6 with the value of 5. So try to understand this by this program. It is very easy. First traverse this code and try to applying in unsorted array. You will definitely understand this program if you will do self. Thank you very much.